this is the first 24 terms of an arithmetic series, 35, 42, 49, up until 196. And then it says calculate the sum of all natural numbers from 35 to 196 that are not divisible by 7, right? So we can see that what they want us to do is that we can calculate all the natural numbers, the sum of all natural numbers from 35 to 196, right? And then subtract those that are divisible by 7. And those that are divisible by 7 are given to us. So it's 35, 42, and whatnot until 196. Those are the ones that are divisible by 7 that they've given us. So if you can calculate the sum of those that they've given us, right, and subtract that from all the natural numbers, right, from the sum of all natural numbers from 35 to 196, and then we can get our solution, right? So let's go about it. Let's first calculate the sum of the numbers from 35 to 196 that are indeed divisible by 7, right? So here, this is what we've been given, say the first 24 terms. So they've given us the 24 terms, right? So we're going to use our formula. Sn is equals to n over 2 into a plus L, right? The reason I'm using this formula is because we know our first and last term, and we also know the number of terms that we have, which is 24 terms, right? So we can just substitute that. So our S24 is equals to 24 over 2 into A, our A is 35, plus our L, which is 196. So we get our S24 is equals to 2772, right? So these are the sum of the numbers that are divisible by 7, right? So we need to get the sum of the numbers, all the natural numbers from 35 to 196, right? And then take that and subtract this total here that we just got. Right, so let's go about that. So now, what is our n here, right? So we're looking from this, we're calculating the sum of all natural numbers from 35 to 196. So how would actually look at this to find our n? Let's just take something like a signal notation. That if we had a signal notation like this, and we had 196 here, and we had 35 here, right? So how would usually find our n, right, which is our number of term? It's top minus bottom, right, plus 1. So we're just going to do exactly that here to find how many terms we are calculating, right, from 35 to 196. So our top is 196, right, minus 35 plus 1, right? So this is what we get. So 196 minus 35 plus 1, we get 162. So this is our n here, right? So now we're going to calculate the sum, right, of all natural numbers. So what they mean is 35, 36, 37, 38, up until 196, right? And then we take that, and then we subtract 2772. So yet again, we can use the same formula because we know the first term, we also know the last term. So we use Sn is equals to n over 2 into A, which is our first term, plus our last term. So we're going to have S of 162 is equals to 162 over 2 into A, which is our first term, which is in this case 35, and our last term they've given us as 196. Right? And then we just punch that into our calculator. Then we get S162 is equal to 18711. So now let's go back to the question. It says calculate the sum of all natural numbers from 35 to 196 that are not divisible by 7. So we found those that are divisible by 7 as 2772, and we found all the natural numbers from 35 to 196 adding up to 18711. So they want those that are not divisible by 7. So we're going to take everything, right, and subtract those that are divisible by 7, so we can get those that are not divisible by 7, right? So I'm going to say sum of not divisible by 7, right? It's going to be 18711 minus 2772. And we get 15939.